let's talk about theoretical versus experimental probability. So theoretical probability is what should happen when you're conducting an experiment. So if you're flipping a coin, you're getting heads 50% of the time, you're getting tails 50% of the time. But experimentally is what actually happens when conducting a probability experiment. So it's possible that if I flip a coin 10 times, I get heads 10 times, even though theoretically it should be a 50-50 split. So we're going to look at some scenarios where we identify the theoretical probability, identify the experimental based on the information given, and then give some new values to it, and then refine the new experimental probability. So number one, a standard dice is rolled 24 times and lands on 2 4 times and 6 15 times. So theoretically, this is a standard dice. So we should get 2, 1 out of 6. We should get 6, 1 out of 6, okay? The experimental probability is based on this information. So 24 is our total. So for all of these, I'm writing my original fraction out of 24. Probability of 2, we landed on it 4 times. We're going to simplify that. They both divide by 4 to become 1/6. For 6, it landed on 6 15 times. These both divide by 3. 15 divided by 3 is 5. 24 divided by 3 is 8. See, if the dice was rolled 6 more times, so now we have a total going from 24 plus 6 to a total of 30. So my denominator for each of these is going to be 30. That's our total. You landed on 2 4 times. So we originally had 2 4 times. Now we have 4 more times for a total of 8. 8 and 30 both divide by 2 to become 4/15. And 6 1 time. So we had 6 15 times. Now we have 1 more time for a total of 16. Those both divide by 2 to become 8/15. Number 2, Brady's sock drawer is filled with 64 individual socks. 16 white, 16 blue, 16 black, and 16 tan. When packing for vacation, Brady just randomly picks 20 socks from his drawer. So that's our total. The results of what he picked are shown in the table below. So we could also total this up, but it should equal 20. So our total for each of these, theoretically, 16, 16, 16, 16. So 16 out of a total 64. Or they're all the same, so 1/4. So for each of these, blue is 1/4, black is 1/4, tan is 1/4. Experimentally, now this is where we have our total of 20. So for white, we had 12. So 12 out of 20, 12 and 20. If you see that they divide by 4 right away, great. If not, anytime you have an even number, divide by 2. 6 out of 10, which simplifies to 3 out of 5. For blue, there's 1, which is just going to stay 1/20th. For black, there's 3. That's just going to stay 3/20ths. For tan, there's 4. 4 out of 20 both divide by 4 to become 1/5. For C, if he needed to pick 4 more socks, so from 20 plus 4 more, now we have a total of 24. So the total for each of these should be out of 24. For white, well, let's look at this. It says he picked 3 blue and 1 tan. So did he pick any more white? No. So our white is still going to say 12. The difference is it's 12 out of 24 instead of 12 out of 20. When we simplify that, we get 1/2. For blue, he picks 3 blue. So we originally had 1. We have 3 more now for a total of 4. 4 and 24 divide by 4 to become 1/6. For black, he didn't pick any more black. We had 3 blue and 1 tan. So black is staying the same. 3 out of 24. 3 and 24 divide by 3 to become 1/8. For tan, 4 is what he originally had. We had 1 more tan for a total of 5. And that's just going to stay 5/24. All right, number 3, about 80% of the population has brown eyes, 10% have blue, 5% have green, and 5% have hazel. Dale conducted a survey in his classes to observe the distribution of eye color. The results are shown in the table below. So, theoretically, we're going to use these percentages that they tell us about the population. 80% of the population, 80 out of 100, which equals 8 out of 10, or simplifying that further, 4 out of 5. For brown eyes, it says, oopsies, I mixed those up. We're going to write this as brown. And we're going to write this as blue. I was going in the order up there and I wasn't paying attention. So brown was 80%. Now for blue, 10% have blue. So 10 out of 100. We divide that by 10 to get 1/10. For green, green has 5%, so 5 out of 100. Divide by 5 to get 1/20. And hazel is also 5 out of 100, or 1/20. Experimentally, it doesn't tell us the total in the paragraph up there, so I'm just going to add 12, 58, 2, and 8. That gives me a total of 80. So my denominator in these should be 80. For blue, it says 12, so 12 out of 80. Again, if I know the right away that these divide by 4, great. If not, they're even, so I divide by 2 to get 6 over 40. But those divide by 2 again to get 3 over 20. For brown, we had 58. They're both even, so I'm going to divide by 2. I get 29 out of 40. For green, we have 2. They both divide by 2 to become 1 out of 40. And hazel, we have 8. 8 over 10 divides by 8 to become 1/10. All right, now last part. Dale surveyed another class of 20 students. So he had 80, he's interviewed 20 more, so now he has a total of 100. So the denominator in all of these should be 100. There were 13 blue, so we originally had 12. We added 13 for a total of 25. These divide by 25 to become 1/4. For brown, we had 2 brown, which we originally had 58. We're adding 2 to that to get 60. That equals 6 over 10, which simplifies further to 3 over 5. For green, we added 1 green to the original 2, which gives us a total of 3. And for hazel, we added 4 hazel to the original 8, which is a total of 12. 12 and 100 divide by 2 to become 6 over 50. 6 over 50 divide by 2 become 3 over 25.